So in previous class I have taught you about the gates, about basic gates, NAND gates, NOR gates, that are universal gates, and XOR and XNOR gates, and how one can design any logic expression by using basic gates, by using universal gates and other gates also. So suppose you can see from the diagram, from the gate level diagram, how one can write down the output expression. You can see, suppose this is say A, this is B, and this is say C, and this is say D, and this is say E, and say this is F. A, B, C, D, E, F. Say these are the input variables, and say this is AND gate, this is 2 input OR gate, these are NAND gates, and this is NOR gate. So what will be the expression for Y for this figure? Okay, so you can see, you can write the output at this gate, it is equal to A and B. Okay, similarly output at this OR gate, it is equal to D or E, that is D plus E. Okay, this is the input F. Okay, then what will be the output at this point? This is say D plus E, D or E, and this is F. So output at this point, it will be D plus E dot F whole complement. This is complement. Similarly, output at this point, it is C, so it is equal to A dot B. This is one input, other input is C dot C whole complement. Okay, then what will be the output at this point? So if you are getting the output at this point, then this will be your output Y. So Y is equal to NOT of these two inputs. Inputs are, say inputs are here, it is say Y1 and say Y2. So Y will be equal to Y1 plus Y2 complement. So it is equal to A and B and C this complement plus Y2 is D plus E dot F complement, then it is whole complement. Okay, you can represent complement like this, or this. Okay, so in this way you can determine the output expression from the given diagram, gate level diagram. So it is clear to all of you? Okay. Now you have to see about about Boolean algebra. Using Boolean algebra, you can reduce any given function. So Boolean algebra has got three properties that you have to study. First one is commutative property, second one is associative property, and third one is distributive property. Okay, so you can see A and B, these are the variables A and B. A plus B, it has to be equal to, it should be equal to B plus A in Boolean algebra, where A may be 0 or it may be 1. Similarly, B may be 0 or B may be 1. You can verify these properties by using truth table also. Okay, these two functions you can I will show you how you can prove this. Okay, first is about commutative property. Suppose A and B, these are the two variables, then A plus B, it is equal to B plus A. Similarly, this is for addition. Similarly, for multiplication, for Boolean multiplication, A dot B, it should be equal to B dot A. Then second property is associative property. It is for Boolean addition, A plus B plus C, it is equal to, within bracket, A plus B plus C. Similarly, for Boolean multiplication, A dot B C, it is equal to AB dot C. This is about Boolean multiplication. This is for Boolean addition. Similarly, this is for Boolean addition. Similarly, this is for Boolean multiplication. Since these are very simple, so I am not proving it. But you can see, third property is about distributive property. Distributive property for addition. For Boolean addition, it is A plus BC, it is equal to A plus B dot A plus C. Similarly, for Boolean multiplication, it is A dot B plus C, it is equal to A dot B plus A dot C. How you can say that this is correct? Okay. So for this, what you have to do, let us take the first one, A plus BC, it is equal to A plus B dot A plus C dot A plus C. How you can say that this is correct? So for this, you have to take this function first, A plus BC. You have to show A plus BC, it is equal to A plus B dot A plus C. Okay. So for this, you can write A, B and C inputs. So there are three inputs. Okay. So possible number of combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1 and 1. So these are the possible combinations, 0, 1, 2, 3, 4, 5, 6, 7. Then you have to determine A plus BC. A plus BC, it is equal to 0. A is 0, B and C, B dot C, it is again 0, so it is 0. Similarly, A plus BC, A is 0, B, C, it is 0. A 0 plus B, C, B is 1, C is 1. So it is equal to 1. A, it is 1. A plus BC, it is 1. A plus BC, it is again equal to 1. A plus BC, it is again equal to 1. A plus BC, it is again equal to 1. Now you have to determine A plus B dot A plus C. What is A plus B? A plus B is 0 plus 0, it is 0, and A plus C is again 0. So this value, it is 0. Similarly, A plus B is 0, and A plus C, it is 1. 0 dot 1, it is 0. Then A plus B, it is 1. A plus C, it is 0. 1 dot 0, it is 0. A plus B, 0 plus 1, it is 1, and A plus C, it is 1. 1 dot 1, it is 1. Similarly, A plus B, it is 1, and A plus C, it is 1. So 1 dot 1, it is again 1. A plus B, it is equal to 1, and A plus C, it is 1. So 1 dot 1, it is again 1. Then you have to see for this, A plus B, it is 1, and A plus C, it is again 1. So 1 dot 1, it is 1, and for this 1, 1, 1, it is 1. So from this truth table, you can see that for these variables, for all the possible variables, for all the possible combinations, input combinations, A plus BC, it is always equal to A plus B into A plus C. So in this way, you can see that A plus BC, it is always equal to A plus B into A plus C. In this way, you can prove this. You have proved this. Similarly, for the second one, it is A dot B plus C, it is equal to A dot B plus A dot C. How you can prove it? Again, for this, you can prove it by using truth table. So you have to write down the possible input combinations. The input variables are A, B and C. Here also you can see the input variables are A, B and C. So these are the inputs, and you have to get A dot B plus C. For each input variable, what will be the value of A dot B plus C? Similarly, what will be the value of A dot B plus A dot C? You have to see. Since the number of variables are 3, so possible combinations, input combinations will be 2 to the power 3. It is equal to 8. So first is 0, 0, 0, second is 0, 0, 1, third is 0, 1, 0, fourth one is 0, 1, 1, fifth one is 1, 0, 0, sixth is 1, 0, 1, seventh is 1, 1, 0, eighth is 1, 1 and 1. Possible number of combinations are 8. So for the first case, you have to see if A is equal to 0, B is equal to 0 and C is equal to 0. Then in that case, A dot B plus C, it is equal to 0. Similarly, A dot B plus C, 0 dot anything, it is 0. 0 dot any variable, it is equal to 0. Again it is equal to 0. Similarly 1 dot b plus c. B plus c, it is 0, so it is 0. 1 dot b plus c. 1 dot 1, it is 1. Similarly 1 dot 1, it is 1, and 1 dot 1, it is 1. Then you have to see a dot b plus a dot c. A dot b, it is 0, and a dot c, it is again 0. So 0 plus 0, it is 0. For the second case, a dot b, it is 0 dot 0, it is 0, plus a dot c. A dot c, it is again 0. So 0 plus 0, it is 0. For this case, for 0 1 0, a dot b, it is 0, and a dot c, it is again 0. So 0 plus 0, it is 0. For the fourth case, a dot b, it is 0, then a dot c, it is 0. 0 plus 0, it is again 0. Then fifth case, 1 dot 0, it is 0. Then a dot c, it is again 0. 0 plus 0, it is 0. Then for this case, 1 0 1, a dot b, it is equal to 1 dot 0, it is equal to 0, plus a dot c, 1 dot 1. So 0 plus 1, it is equal to 1. Similarly, a dot b, it is equal to 1. It is, you can see, 1 dot 1, it is equal to 1, plus a dot c, 1 dot 0, it is 0. So 1 plus 0, it is equal to 1. Similarly for this case, 1 dot a dot b, 1 dot 1, it is 1, and a dot c, 1, 1 plus 1, 1. This is logic addition, 1 plus 1, logic addition, it is 1. So from this truth table you can see a dot b plus c for this input combination, for all the input combinations you can see both are same, outputs are same. A dot b plus c, it is equal to a dot b plus a dot c. So in this way you can say that this is correct, that is you have proved this, that a dot b plus c, it is equal to a dot b plus a dot c. So it is clear to all of you, duality principle. In previous class I have discussed about De Morgan's theorem, but in this class you can see about duality principle. What is this principle? Suppose y is any function, y is equal to say a dot b plus a dot c. You can get the dual of any expression by converting an operator to or to and 1 to 0 and 0 to 1. You can get dual of any expression by converting AND operation to or to AND, similarly 1 to 0 and 0 to 1. In this way you can get the dual of any expression. Suppose you want to determine the dual of this. Suppose a plus a, you know a plus a, it is always equal to a. So what is the dual of this? Just now I told you that for determining the, suppose this is any expression, logic expression, this is any logic expression. So the dual of any logic expression you can determine it by converting this or operator with and. A dot A, it is equal to A. It is equal to A. Okay. So you have to simplify any logic expression by using Boolean algebra. So you have to know some basic rules. Suppose you are adding 1 plus any variable. If you are adding 1 with any variable, it will always be equal to 1. It is always equal to 1. 1 plus 1, it is also equal to 1. So you can see 1 plus 0. Any variable has got only two values. Either it may be 0 or it may be 1. So if it is added with 0, then also you are getting 1. If it is added with 1, it is logic 1. This is logic addition. So 1 plus any variable, it is always equal to 1. Then you can write 0 dot A, it is always equal to 0. 0 dot A, it is always equal to 0. If you are multiplying, means with any variable with 0, it is always equal to 0. What would be the dual of this expression? Dual, you have to, what is the dual of this? Can anyone say how you can determine the dual of this? 0 has to be converted to 1. Then this is and operator. So you have to convert and operator to or. 1 plus A, it is, then you have to convert 0 with 1. So this is the dual expression of this expression. 0 dot A, it is equal to 0. So what is the dual of this expression? Dual, how you can get? You have to convert 0 with 1 and with or. A, it is the same. Then 0 to 1. So 1 plus A, it is equal to 1. So this is the dual of this expression. Okay. Then you can write A plus A complement. It is equal to what? A plus A complement, it is always equal to 1. How you can prove it? If A is 0, complement is 1, it is equal to 1. If A is 1, its complement is 0, it is equal to 1. So any variable plus its complement of the variable, it is always equal to 1. You can prove it like this. The value of A may be 0 or it may be 1. If it is 0, 0 plus complement of 0 is 1. So 0 plus 1, it is equal to 1. Similarly, value of A, if it is 1, 1 plus 0, it is equal to 1. Then A dot A complement, what it may be? It is equal to 0. It is equal to 0. You can prove it. A may be 1 or A may be 0. So if it is 1, it is 1 dot 0, it is equal to 0. Similarly, if A is 0, complement of 0 is 1, it is again equal to 0. So in this way you can prove A dot A complement, it is equal to 0. So you have to know the basic theorems or basic rules so that you can simplify any logic expression, any Boolean expression. Then you can write, this is very important, A plus BC it is equal to a plus b into a plus c. Just now you have seen its proof. This is very important for simplification by using algebraic method. A complement, then again complement, it is equal to the same variable. Suppose a may be 0 or it may be 1. If a is 0, its complement is 1, then complement of 1 is 0. Okay, so in this way you can say that, suppose for the first case a is equal to 0, then a complement it is equal to 1, a double complement it is equal to 0. So both are same. This a double complement it is 0, 0 it is equal to a. Reduce this function. Suppose y is equal to ab plus ab dash, ab plus ab dash. How you can reduce this by using algebraic method? Then you can write a, you can make it common, b plus b dash. You can write like this. Now you can write a, b plus b dash. What it is? B plus b dash. It is always equal to 1. So it is equal to a. This is the logic, any Boolean logic expression. So by using Boolean algebra, you have reduced this function to a. So by using Boolean algebra, by using some principles and some rules, you can reduce any Boolean function. Okay, y is equal to a dash b plus a b plus a b c. Suppose we have written this, then how you can reduce it? It is b a plus a dash plus a b c. So it is equal to b plus a b c. So it is equal to b 1 plus a c. Now you can write 1 plus any variable, it is always equal to 1. So it is equal to b. So y is equal to b. This is the simplified. After simplification you are getting the expression of y. So you can verify it by using truth table also, that a dash b plus ab plus abc, it is always equal to b. By using truth table you can verify it. Reduce the following logic functions by using Boolean algebra. First is y is equal to a b dash c dash plus a dash b c plus a dash b dash c dash plus a b c. This is the first expression, Boolean expression. Then second, y is equal to a plus b plus c, a plus b dash plus c into a dash plus b plus c dash. This expression. So try to reduce these two Boolean expressions by using Boolean algebra. Okay, so you have to use some rules, you have to use some postulates, you have to use some theorems, Boolean theorems. Okay, then you can write the dual of the following logic expressions. This is say A and this is question B. First is y is equal to AB, A dot B plus A dot C. Okay. Second, A plus 0, it is equal to A. Third, A dot A complement, it is equal to 0. Fourth, A plus A complement, it is equal to 1. Like this. So what would be the dual of these functions, these logic expressions? Write the complement of the following logic expression and reduce the expression by using Boolean algebra. First is y is equal to A plus B plus C, A dash plus B dash plus C dash, A dash plus B plus C dash, whole complement. Second is y is equal to A B C plus A dash B C plus A B C dash plus A dash B dash C dash, whole complement. So first question is y is equal to complement of this and this. Similarly, this is the second one. So for this you have to use De Morgan's theorem. How you can complement this function? By using De Morgan's theorem. You can use De Morgan's theorem. Then after using the De Morgan's theorem, then you have to use Boolean algebra to reduce the complement. Okay. Similarly, for the second one, you have to again use the De Morgan's theorem. Then after using the De Morgan's theorem, you can reduce the complement by using Boolean algebra.